Hello everyone, welcome to BetNet. This is Roshan, and today we'll be delving into the OSI model and uncover some of the misconceptions that people have around it. So let's get started. So what exactly is an OSI model? Well, it's just a template that tells how two computers can communicate with each other. As simple as that. To give you an analogy, just think if you were living in the 1900s and you wanted to send a letter to your friend who's living across the end of the city. So what would you be doing? You will be writing the letter first, putting that in an envelope, adding the addresses, the stamps, etc., and finally putting it out in the mailbox, right? The mailman would come, he'll collect the letters, sort them out, and finally deliver it to your friend, right? Something similar happens with computers as well. The OSI model defines a series of steps that the computers must take so that they can communicate with the other party. Or alternatively, we can say this, for the data that this device has to send, the data has to undergo a series of steps, and at each step, some information gets added, which eventually leads to the actual delivery of the data, right? So, hope that's clear. Now we'll try delving into the individual layers to understand their significance. So I have two devices in here, device A and device B. And usually in the OSI layer, we have OSI model, we have 7 layers. And typically layers 1 to 4, that is from physical layer to transport layer. In these layers is where the actual networking happens. The last 3 layers, that is from application layer to session layer, this is usually incorporated into the application itself, and we can ignore it for now. We can just think these 3 layers as the data itself, right? Okay, so now device A has got some data to send, right? And the first thing that device A will decide is whether it needs to inform device B about it or not. So device A will think, should I need to inform device B that I'm sending him a data? If yes, then device A will go ahead and tell to B, hey, I have some data to send. Do you want to receive it? If yes, device A will go ahead and send the data. Otherwise, it will just close the connection, right? In the other case, device A will just directly send the data to device B without even informing it. So this happens in the transport layer, right? This decision is usually taken in the transport layer, and it is done using two protocols. One is TCP, Transmission Control Protocol, and the second one is UDP, User Datagram Protocol. So with TCP, the device will always form the connection before sending the data, whereas in UDP, you just directly dump the data to the other end, right? So each of these approaches have their own advantages and disadvantages, and applications usually choose one of those depending on their use cases, right? So now that the data is encapsulated with the transport layer information, right, it comes to the network layer where we add the relevant network addresses. So in this case, we have added the source and the destination as the network address of device A and device B respectively, as in this diagram here, right? Now that you add the network address, you go to the data link layer next, where you add another form of addressing, and this is usually the hardware addresses of the devices. So if you see here, the source is the hardware address of device A, and the destination is the hardware address of device B. Now, one question that might pop in your mind is, why are we using two addressing schemes? Like, can't this work with just one kind of addressing, either network layer addressing or data link layer addressing? Well, to answer that, we can go back to the example where you were writing a letter to your friend, right? So you won't be just writing the house number of your friend, right? You'll be writing the street address, you will be writing the area address, and the zip code as well along with the house number, right? So in the real world, these two addressing scheme helps in actually efficiently delivering the data to the other end, right? And I have a better example that instills this concept. So let me go to the right. Yeah. So I have a map in here. So let's say you're trying to travel from Salt Lake City to New York, and you're traveling in a car. It's a pretty huge journey, right? And you won't be directly going from Salt Lake City to New York, given the huge journey. You'd be having some pit stops or checkpoints, right? So, for example, although your ultimate destination is New York, your immediate destination Our goal would be to reach Chicago, and from Chicago, you will go to New York, right? So something similar is depicted in the above diagram. So the previous diagram which we were inferring to here, device A and device B are directly connected, but here, let's say device B is a few hops away, right? And these things that you see here, it represents the packet that is traversing through each of the nodes. So notice one thing, that the network layer information which has the ultimate source and the destination, it never changes, right? In every packet that you see that is traversing through the nodes, it never changes. What changes in that is the data link information. So let's go through this flow once. So when the device A is sending a packet to device B and it's a few hops away, here's the packets that's getting created, right? Then here's the network layer information and here's the data link layer information. The from is the hardware address of A and the destination is the hardware address of router 1. When the packet reaches router 1, it first looks at the data link layer, and looking at the destination field in the data link layer, it is destined to itself, right? Router 1 sees that the packet is destined to router 1 sees the packet is destined to itself. So it tries to uncover the packet further and looks at the network layer. Now at the network layer, it sees that the destination is not itself, but the destination is something else. So it understands that, okay, this packet is not destined for me, but it is made to be going through me, right? So now what it does is it builds another data link information and adds on top of the packet. And this is what you would be seeing when it is traversing out of the router 1, right? So here's the data link information. The data link, it says the source is now router 1 and the destination is now router 2's hardware address, right? Same thing happens when packet reaches router 2. Router 2 thinks, okay, looking at the data link layer, that it is the packet is destined to itself. But when it uncovers it and looks at the network layer, it sees that, okay, it's destined to some other device. So the packet it's just traversing through me. So it will build the data link layer information again. And this is what we would be seeing when it's traversing out of router 2. This is the source, which is router 2's hardware address, and this is the destination, which is device B's hardware address. And eventually the packet makes it out to device B and device B gets the data, right? So this is how the two addressing scheme is actually helpful, right? So let's go back to the diagram. Yeah. So once we have the packet getting created, it is now converted to ones and zeros and is actually sent onto the wire. So device B will eventually receive those bits and it will create the packet. And now it will do the same process, but in reverse direction, right? It will try to uncover each and every layer and eventually it will get the data, right? So this is how the communication happens and is defined by the OSI model. So, and going over these three layers, which we skipped a while back, I'll just go over them briefly. So the application layer is nothing but it defines the protocols that initiate, send, and receive the data. So for example, let's say I'm trying to Google something out on this web browser. It is trying to request some data from the Google server, right? And how the data is requested is using protocols like HTTP and HTTPS. There are many application layer protocols like SSH, Telnet, and you can look for it. But the most common ones are HTTP and HTTPS, which are being used by web browsers to, send to send the data between servers, right? Next comes the presentation layer. And in this layer, we make sure that the data is formatted in a way that it is understandable by the device on the other end. So we might format the data in ASCII format or Unicode format or in any other format that device B understands, right? And also typically in this layer, we do the encryption part. So if you want to encrypt the data, we do in this layer itself, right? Now, next comes the session layer. The session layer is important for managing and controlling the session. So let me help you understand what that exactly means. So let's say this represents the one physical connection between device A and device B. Although you have one physical connection, you can have multiple logical sessions between the devices, right? So let me just space this out. Yeah. So here you're having one physical connection, but you're having many logical connections. And an example of that would be you opening multiple YouTube pages on your web browser, right? Although you have one connection to the YouTube server, one physical link between you and the YouTube server, you have many logical YouTube sessions open on your browser, right? So that is what is defined in the session layer, right? So this is what there is to the OSI model, and I'll just show you a quick packet capture to see how a packet resembles these layers and how it actually follows the OSI model. So yeah, so what I have on the right is a packet capturing tool, and I'll just try Googling something out and let's try to capture the packet. So on my left, I have a VM and I'm just trying to Google something. So this is equivalent to you Googling something, right? So let's follow this flow. Just ignore all of this for now, right? Yeah. So this is the exact flow that is captured when I'm trying to Google something. As you can see, it says protocol TCP, which means my PC tried to form a connection with the Google server before actually requesting or sending any data, right? So these three things, it's called as the first three packets that you see here. It's part of the negotiation process that you see here, right? And post the negotiation is done, you can see my device is requesting for some HTTP data, right? And on the right, you can see the packet dissected here. And this gives a good overlook of the packet itself. You can see the HTTP protocol itself, it has some data and it is encapsulated inside the transport layer in a protocol. And TCP is being used here, right? We can see here. And that is again being encapsulated into the network layer protocol, right? And that is again getting encapsulated into a data link layer protocol, which is Ethernet in here. So I'll just try to open these packets one by one. So again, this is the HTTP protocol. You can see some data inside of it. And you have the TCP control protocol here, transport layer protocol, sorry, transport layer protocol, and we are using TCP in here. And you see something like port numbers in here. So maybe I'll again go over the port numbers a bit. So let me just go to the right. Yeah. So so usually port numbers are used in the transport layer information, and I'll tell you why it's used. So let's say you have your web browser and you're trying to open multiple sessions for multiple sites. So you have Gmail, you have Facebook, you have YouTube, right? And you have only one computer interface, right? It will be typically connected to a Wi-Fi or Ethernet, and it is making connections to the Gmail or Meta or YouTube or whatever. So now, how does the interface or web browser know that the packets that egressing or that's coming into the interface, it belongs to the Gmail tab or it belongs to the Facebook tab or the YouTube tab? On looking at this diagram, it makes sense that if we have some color coding, it's easier to distinguish, right? So something similar is being done in the transport layer using port numbers, right? So the combination of source and the destination port numbers, it forms a unique session, and that way we can identify which tab the packet belongs to, right? This is a very simplified explanation, but that's the gist of it. Okay, now let me go back to the capture. So now we have the network layer information here, and you can see we have some source addresses and destination addresses in here. And then comes the data link layer. Again, you can see the source and the destination here, right? Since I'm using a VM, you might be seeing two Microsoft MAC addresses, but typically you would be seeing the source as your PCs and the destination would be of your routers, right? So this was the packet capture that uh, I wanted to share with you guys, right? Now, let's go back to the diagram. So there are a few misconceptions around the OSI model. So one of them is, let's discuss about it. So one of them is people think OSI model is some kind of a programming language or a software or something of that sort. But in reality, just a framework, right? It's just a framework that tells how two computers can communicate with each other. That's it. And the second one is people think this is a hard-coded model, as in, so let me just scroll back. Yeah. So people think this is a hard-coded model. What I mean by the hard-coded model is, so people say, okay, if I have some data, the data must go through each and every layer in the OSI model and then make it out on the wire, right? Whereas in reality, it's not like that. And it depends on the application itself. So some applications might skip using transport layer itself and the network layer as well, right? It depends on the application. It's not like you have to go through each of the layers, right? And second thing is uh, some protocols in data link layer might be using the features of a protocol that are present in the transport layer as well. So there's a mix and match of everything. It's not hard coded. It's just a framework. It's up to you. You want to follow that. And most applications try to follow this, right? But there are some custom applications where they might try to use their own protocols, or they might cut short the layer, add their own protocol, something of that sort, right? So it's not a hard-coded model, just a framework that tells how to communicate two devices communicate with each other. That's it, right? So yeah, so that's all I had on the OSI model. So let me know if you have any questions in the comment, and like and sub if you found it helpful. And thank you. See you in the next one.